and probability is always between 0 and 1. 0 being it can never happen, never. And 1 mean it's guaranteed to happen. Can I get some answers in the chat? What are some things always guaranteed to happen? Yeah, again. All right. Yeah, anybody, and if you want to shout it out, that's also fine. Let me see. Do I have, can participants unmute themselves? I think so. Yeah. What is, can anybody tell me an event? Something that is always guaranteed to happen. All right, I'll start. I guess I'll start us off. What some event that is guaranteed to happen is that, let's see. I'm gonna say that a coin will always land heads or tails, or it could land on its side. But yeah, that's a bad example. I wanna okay. The probability is also used for weather forecasting, medicine, and analytics. And okay, let's start off with our sample question. Now, this if you read the email that the Robotics Academy sent you, you would it gave you a sample question that would kind of describe our session. You got a jar with 6 red, 4 green, and 2 black socks. Without looking, what's the minimum number of socks you need to pull out to guarantee a matching pair? Assuming you draw one sock, set it aside, and then draw another. Now, if anybody has any answers, that'd be to shout it out or put it in chat. That'd be fine. Okay, I got an answer in chat from Vikram Tadanada that it is 4. Vikram, would you be willing to explain why to the class?
Yeah, sure. So, um, if you want, it says how many do you need to take out to guarantee. So you need to do it for like the worst case. So so if you take one of each color, then you just need to draw one more. No matter which color you draw it from, you'll have a pair. So if you're unlucky and you get 1 red, 1 green, 1 black, you just need to draw one more. So 4 socks.
That's an excellent explanation. Thank you, Vikram. All right. So you guys heard him. The answer is 4. Any questions on that? Or can I move on? Oh, okay. Okay, looks like everybody's fine. I'm going to go to the next slide. Oh, right. Okay, so this time the question is a little different. You got to draw again with the 6 red, 4 green, and 2 black socks. What is the minimum you need to pull out? What is the minimum you need to take out to guarantee socks of 2 colors? Assuming you drop. Oh shoot, no, this is wrong. Okay, what if you got? Okay, sorry, you got a jar with 6 red, 4 green, and 2 black socks. Without looking, what is the probability we pull out 3 socks of 3 different colors in 3 pulls? This is kind of referring to that earlier question, but instead I'm gonna ask you, what is the probability that in 3 pulls we pulled 3 different color socks out? Has anybody gotten an idea or an approach to how we can solve this, maybe? Or right, so what I'm gonna do is I'm just gonna I'm gonna I'm gonna quickly annotate like how it's done. So basically, let's say, you know what? Let's say we pull out a red sock first. Now, what are the chances of pulling out one red sock? Now, that would be there's six red socks, four green, and two black socks. In total, six plus four plus two would be 12, right? And but we want six red socks. We have six red socks, and we're saying we're drawing out one red sock. Now, the probability of this would be would be socks, six red socks, or 12 total socks. Now, what is the now this simplifies obviously to one half. Okay. So now what we would do here is we got one half so far, and we put our question says that we put them back and then draw another. So what that means is after we draw that red sock, we got to put it back and then we just draw another. Let's say we get a green one because it says what's the probability of three different colors in three pulls. Let's say we pull a green one next. Now the probability of this would be four. We have 12 total socks again. Oh, and we need to put that over the total. We need to put four green socks because that is the and then they'll give us the probability that we pull out a green sock. Sorry, that's then. And then after we pull out that green sock, we so far we've we got red and green, but we need black because that's the question. That's the conditions of the question. And now black has a really small probability. It's on it's only it's only two black. There's only two black socks in that jar out of 12 total. So it's a really small probability, but let's just say it happens. This would be one six over six to for simplifying. Yeah. And now once we got all these numbers, we got one half, one third, and one sixth. Okay. What do you reckon I do with them? Any Has anybody got any approach? What do I do with these numbers? Yes, I multiply them. That's precisely correct. We have to we and why we multiply them is anybody know why we multiply them? Okay, so basically why we multiply them is we we gotta all right. Why we need to multiply them because we gotta take multiplying is the way to take the to combine the probabilities basically, and because we need all of them to happen. We cannot just add them up because that's if you add them up you get one. That means one of them is gonna happen in one pull. We need all of them to happen on the first pull. We need we need to get the red sock, which again is a it's a one half probability of pulling the red sock. In our second pull, we need to get the green sock, and our probability of that is again one third. So we had to multiply these cases, and so and on our third pull we need a black sock, and since there's only 2 out of 12 total black socks, we the probability of that is 1/6. So now when I multiply these out, what do I get? Oh, come on. All right, 1/36 would be my final answer, and that is the probability that in three tries I draw these 3 socks. Yeah. I can't hear. Is it just me? Is anybody else having some difficulties hearing me speak or Manvik, can you hear me?
Yeah.
Okay. All right, I'm gonna go on to the next slide. Now, this one is a little different. If you read the question, if you when reading the question, can anybody tell me what's different from this question and the last one? And I prefer if it's somebody else other than Vikram, if because I want all of you to participate. Okay, well, we got another answer from Vikram. He's rocking on. Okay, so he was right. This time, instead of putting the sock back in the drawer, we're removing them. We're not putting back in the drawer, we're setting it aside. This is if you read that part, and so basically the probability of us pulling 3 socks of 3 different colors in 3 pulls. It's not gonna be our previous answer 1/36 anymore because every time when we pull out a sock, there is one less sock the next time we pull out one. So what is our approach to this question? Or you know what? I'm gonna say on our first pull, what is the probability let we draw out a green sock? Let's start with off with green this time. Yes. Fine. Nice. We got an answer, 4/12 or 1/3. Yes, I like 1/3. That's better. It leaves us with smaller numbers to multiply in the end. And now that we pulled out a green sock, how many socks are left? Remember, there are 12 socks in total. 11, that's correct. Okay. So now that we got 11 socks, we're gonna say we had to pull out uh, a red sock. And now that now how many we gotta multiply how many red socks there are, how many favorable outcomes over the total possible outcomes there are. So we got something over 11, which would be what? 6 over 11. That's correct. All right. Now we now that we now that we pulled out a green and a red sock, we only have 10 socks left. Am I right? So now how much? Now we need to pull out a black sock. And what is the probability of us pulling out a black sock now that we already put that 2? Yes, 2 over 10, or we're gonna simplify that to 1 over 5. I'm gonna put the probabilities I'm gonna put the unsimplified probabilities below, so like if anybody everybody can understand the process. But yeah, and now if we just basically now we can just simplify and then multiply. That would give us, this is obvious, but Yeah. If we multiply all these probabilities out, what would this give? What would it give us? 2 or 55, that is correct. All right. We're gonna go to something a little different now. Wait, shoot. I'm gonna just quit. All right, now on to like a little different kind of probability. Okay, so now we got 4 light switches. There was, I don't know, just, and here's our question. How many combinations of on and offs are there in these 4 switches? For an example, one could be on, another could be off, the next one could be off, and another one could be on. How many combinations? You could also track instead of saying, now don't skip to answers just yet. I always like hearing a thought process, so instead, you can also just say 1 as an on, 0 as an off, 0 as an off, and 1 as an on. Now, if we were to like, just draw every case, which is called casework, by the way, just like we're drawing every case, that would take a little bit too long. What's a better approach to solving this problem? Okay. So I'm gonna start you guys off with a question, just a little bit easier than this. Okay, a lot easier. For just one light switch, okay? Let's not focus on these 3 for a moment. For just one light switch, what are the what are the possibilities of this light switch? What could it be? On or off? Right? There's two combinations for this one. And we're and so what are there okay, I'm gonna now let's take 2. Let's take a second light switch. How many combinations for that? That would be the same as our previous light switch, right? There's no tricks, guys. They're the same type of light switch. Doesn't have anything special. Okay, so that would actually not work. Basically the second one also has 2 combinations. I'm gonna put as like light 1, light 2. Okay, and now the third and the fourth will also have 2. So after 2 combinations each. Now you know that they all have 2. They could all be just on or off. How many combinations do you think there are? Yes. Yes, that's correct, Artha. 16. And now, I want to know, how do you get this answer? If you could put it through the chat, or you could just shout it out. Yes, that is correct. You would multiply them all, since either can happen. This could be on or off. This could also be on or off. And this could be on or off again. And that goes for all of them. So when you multiply them all, you get a total result of 16. And that is our answer to this question. Okay, now this is a little different. What is the probability that there are just 2 switches on? So basically, going back to our previous example, I'm just gonna say this is light 1, and then 2, 3, and 4. And then the possibilities are on and off. Oh, on and off. On and off for basically for all of them. Now, what is the probability that there are 2 switches on? That means exactly 2 switches on. It's not at least exactly. There cannot be 3 or 4, just 2. Anybody got an answer there to say they would think? All right, so I'm just gonna start us off by saying we need imagine these four these 4 light switches. We need to pick 2 of them. Just we need to pick 2 that would have a light on. 2 of them that the switches are going to be on, and the rest of the 2 of them in that case would be off. Now, how would we focus on that? All right, I'm gonna try making this easier. Okay, let's just say they are all off. And we need to pick 2 of them that we're gonna turn on. Now, what do you think? What do you think is like the probability of, or what are the combination? What are like what is the probability that there are 2 switches on, and like what are the combinations? Okay, shoot. Okay, I got an answer. 3-8. How? So, Vikram, would you like to explain your thought process behind this answer?
Sure. So the combinations for there to be 2 light switches on, there would have to be 2 off also. So if you count them all, you can see it's on, off, off, on, off, off. I mean, yeah, on, off, on, off, on. So if you count them all, there's 6 combinations, and those are the ones we want. So 6 out of the total 16 combinations would be 3/8.
So in other words, you used casework, right?
Yeah, but you could also see that so you could so the total ways to rearrange them would be 4 times 3 times 2 times 1. But you're over, like, if they're all different items, then you could put the total ways to rearrange them would be 4 times 3 times 2 times 1. But you have to divide by 2 because the offs are the same and the ons are the same, and then you have to divide by 2 again because of the offs, and so you get 6.
Well, yeah. So basically what he is saying is, or basically how to solve this problem is to to pick 2 that are on. For our first, we need to pick 2 of them. If imagine they're all off. Like, okay, in this picture they are physically all off. To pick, let's say we're trying to pick one of them that needs to be on. How many choices do we got for that? We're gonna flip just one of them on. How many choices are there? If I could get an answer through chat, would that be good? Cool. Okay, so yes, that is correct. There are 4. Because we can choose from one of these 4 light switches, and there are 4. Okay? So now that we picked one of them, we need to pick the question says we need to pick another one. So now let's say we pick this one, and now this one is on. Now, how many choices are left for our second switch to be turned on? 3, that is correct. Okay. So now, okay, so now that we got that, let's say we turn this one on. What what would we put in the denominator? Like, how many total cases are there? Okay, so basically how many cases are there refers to our bill of problem. How many combinations of like on and offs are there? 16, yes, because that's how many combinations there are. That is correct. Okay, so but this answer does gives us 12 or 16, which is not correct. Can anybody explain why? What did I miss here? I'm gonna just erase this part. What is something we are missing? Okay, I'm gonna give you a clue. This is so okay. I'm just for sake of class time, I'm just gonna tell you all. Basically, what we did not account for is the order of the switches being turned on and off. Let's say that out of these two switches, let's take shoot, let's out of these two switches. Okay, I'm just gonna out of these two switches, they're both on. But why is this? Now, what if we had picked this one? What if we had picked, this one right here and then this one after? Or instead we picked this was our first choice. Not, this switch right here was our first choice and then this one was our second one. That would give us two ways to pick them in different orders, but that doesn't matter but since they're in the end, both of those switches are going to be on anyway. So how many cases, if I'm picking like one of these, how many cases are there? Like if I'm picking this one or this one, how many cases like of which would I pick on and off? It's a really simple answer. Just if you count this up, you'd get okay, I'm just for the purpose of class. Vikram, do you think you can spot us an answer on this one?
Uh, so because the offs also you're double the offs also can be switched. You're counting the offs twice also.
That is correct, but like imagine they're all off and we're just turning two of them on. We're not choosing two of them to be off.
Yeah. So
So no, what are the if we imagine these two switchers are both we turned them on, but what if we had picked this one to be on
oh,
first and then this one
because
on second?
when you're counting the 4 and the 3, let's say you pick the first switch and then the second switch. That's the same as picking the second switch and then the first switch. So
That is
that's what.
correct. So that means there are two ways to pick those two switches and they're two orders. So that means we had to add those two cases to the denominator, which would give us in the end 12 over 32. It simplifies to 3 over 8. 3 over 8. Okay, I think we're gonna go to our Kahoot right now after this. Let's hope it works though. All right, I'm gonna. Oh no. Okay, so I'm gonna host a live Kahoot right now. Let's just see it load up. We're gonna do classic mode. And I am sharing my screen right now. I'll paste the code in chat if you guys need it. You can get to enter this game, you could go to kahoot.it and our yeah, the ID is the game pin is posted right here. I'll copy this for you guys. All right, now let's see how many. Okay, so all right, I think we got participants, 5 participants. I'm gonna I'm gonna give you like 10 everybody, the rest of you 10 seconds, and I think I'm gonna just start this off. Now I'm giving you a lot of time on these answers, and so please decide. Please like really calculate this out. Try deciding wisely. All right. Well, it looks like we got some answers here. Everybody picked yellow. Just there's a little glitch out here. This is a little surprising. Okay, so if we look at the leaderboard, we see Arthur's in first with 0 points. This is all right. I don't expect you guys all to get all these correct, but yeah. I'm gonna go on to our next question. So, and by the way, I just found out our previous answer was wrong. That was an error. I'm sorry about that. The answer was indeed the one you all picked, 2 heads and 2 tails. Hold on. Did this freeze? Or were you guys able to pick an answer? Or was there something wrong? Okay. I'm gonna go to our next one. I'm gonna help you guys out on this problem. So let's imagine that for the product to be divisible by 3, um, let's say that for it to be divisible by 3, let's just say that the first dice is divisible by 3. I'm gonna imagine these are dices. Let's just say the first dice was divisible by 3. That mean it would have to be 3 or 6. And the rest could be anything from 1 to 6. It doesn't matter because and then now we got there's 6 cases for this dice and 6 cases for this dice, but since we need a product, we need something that's divisible by 3, we got 2. And this could go for all dices, by the way, because it could be this dice that's divisible by 3, this one, or this one. So we multiply it by 3. I guess that was a little late. I just wanna ask, is anybody like able to do the Kahoot? Or are the answers too tricky or like something? Could be good. Sorry, wait, could I get an answer again? Is anybody able to hear? Is anybody able to access the Kahoot? All right, it's fine. Okay. I'm gonna just go back to there. Let's see. This is a true or false question. Okay. We're getting some answers here. All right, so I can honestly quickly explain these problem. Let's say there are 5 switches that are on and off. Let's say all 5 of them start as off. I'm gonna put okay, it's a bad color scheme. Let's say all of them are off. And we need to pick 3 of them to turn on. Now, basically, let's say we pick these. Let's say our our first switch we have 5 choices because there's 5 switches, and then our second choice we have 4, and then our third choice we have 3 choice, and our third choice we have 3 left. So, which would and how many total cases are there? this would be 2 times 2 times 2 times 2 times 2, or 2 to the power of 5, since each has 2 cases. But there is something we could need to account for, is the order. Because this could be our first, this could be our second, this could be our third, this could be first, the second, third. This could be our first, and this could be second, third. It could be in this way. It could be in this way, or it can be in this way, which gives us 6 cases. So we put that in the denominator also. And if we were to calculate this out, we could do this, get 2, and we could take this, get 2 right here, which would give us 10 over 2 to the power of 5 is 32, which should simplify to 5 over 16. So that's why it would give us 2. Right. Okay. I'm actually gonna stop this Kahoot, honestly. I think I think there might be some issues in there. So I'm gonna actually go back to the slides here, and we're gonna take on a little different questions. This is diagram probability. So the imagine, have you guys, I'm pretty sure you guys have all seen this. This is a Venn diagram. And what this circle represents, the probability, this circle represents like something. It could be the probability, or like something that fits into something that fits some criterias. This circle represents the other one, and one that and if something fits both criterias, then it would go in the middle. And the probability and the this probability of A plus the probability of B minus the intersection, because we're counting them all. Oh, shoot. Would give us 1, or also it would give us a probability of this. Okay, but that's not extremely important for at least for this session. So I'm gonna head on to our next slide. Now imagine this. We got a class of we got a class of 200 students. 120 study math, 100 study science, 80 study English, 60 study both math and science, 40 study both science and English, 30 study both math and English, and 20 study all 3 subjects. Now, we need to find the probability or of studies, like of students who study math or science but not English, students who study exactly 2 subjects, or students who study at least 1 subject. Now, this looks like a really tricky problem at first, but what is what is a box that we can immediately fill out? This is a 3-way diagram. So this spot this right here would fit, would fit um N and S. It fit both those criterias, which means they would this one right here means they study both math and science but not English. This one would mean they study math and English but not science, and this one would say they study science and English but not math. And this one is they study all of them, all 3 subjects, and these boxes mean they only study that own subject. Now, what is one box we can fill out immediately? I want you to look at the last statement right here. Vikram, do you think you could spot us an answer here?
Yeah.
So on our last,
So 20 said, so that's the mid, so the 20 is the middle.
okay,
So we want, so if, and though, so we want math or science, but not English.
okay.
So that would be just that, wait, shoot, okay, so that would be only math plus only science plus math or science, but not English. So
And
that,
since 20 study all three, but
yeah.
we got 60 who study both math and science.
Yeah, so we have 40 that study math and that are in the intersection that study both math and science but not English. So we have
Okay, that is correct. Okay. So we would get 40, that's right here. And then
yeah. And we have 120 that study so yeah, we also have 30 that study both math and English. So 10 study math and English and not science.
okay.
And the total math is 120. So if you subtract all of those,
Subtract
yeah, if you
120
subtract,
from 40
yeah, 20 and
minus
10.
20 and minus 10, that would give us,
The only math which is 50.
all right.
And then the science and English is 40. So if we take away the 20, the only science and English is also 20.
Okay.
Yeah, and
And
100 study science, so we can subtract again. So
so that would give us 20.
yeah, that would give us 20 there.
And
So
then
now
for
we want
English,
math or science but not English. So we add 20, 50, and 40. But there's, and so that's 110. And we want the probability. So
wait.
110 students.
So we filled out every box except English.
Yeah,
Did
we
you say
could.
the answer for the English or
Yeah, we could do English for the yeah. So
like only English?
yeah, only English. So we have 80 minus the 20 that study all minus the 20 that study science and English only minus the 10 that study math and English only.
Which would give us 30.
Yeah.
Okay. So I'm just gonna clean up everything a little bit, take out all these confusing things here. All right. So basically looking at this information, it isn't too hard to find out you know, to find out like the probability the how many students do exactly which activity. So now we need to address the questions, which is find the probability of randomly selecting a student who studies math or science but not English.
So we could
Which would be which box?
the 50, which is only math,
Or
plus
science, but it says.
yeah, and then the 40 which study math and science at math and science and not English, and the 20 that study only science.
That is correct. So we we basically get this. This does not intersect with the English section at all. And
Yeah.
so what we need to do is add all these up, which would give us 110. Oh no.
Wait, that's,
All right.
I think there's a shoot,
I think
yeah, I
you're
think there's
correct
a
actually.
yeah, I think something.
Or
Yeah, it's supposed to be 120.
Is that so?
Nice. For the math.
Yeah, we got 50, 40, 20, and 10, so which adds up to 120.
Oh yeah, okay.
Okay.
Yeah, never mind. Okay, so yeah.
You good, you good? Okay, so that's the answer to our first question, 110. Our second question is studies exactly two subjects. Now, which grids like study exactly two subjects?
The 40 with yeah.
10 and because it says exactly, it doesn't say at least. Now, if we add those up, that would give us 70. And studies at least one subject. This one's a little more interesting. But one thing we could do is since we got all the since we got the prob since each grid represents that, like, since the number of students, since there are 30, the 30 in that P of E, that represents the kids who only study English. There's 20 kids who only study science, and there's 50 kids who only study math. And then there are the rest of them, 40, 20, 40, 20, 10 are kids who study two subjects, and 20 who study three, because it says studies at least one subject. So if we add all of these boxes up, what would we get?
200.
Well, yeah, let's try them. Let's try it out. Okay, so we got 50 plus. Okay, I'm just gonna let's start out with kids who study. Let's start with kids who study just one subject, 50 plus 30, 20 plus 30, which gives us 100. And then kids who study two would give us we we would get 40 plus 20 plus 10, which is 70. So we got 100 plus 70 so far. There's only 20, there's 20 who study three subjects. So that would give us 190, which means there are not 200 who study
Oh,
all subjects.
oh
There
yeah.
are there are 10 kids who do
They
not
don't
study
study
anything.
any. Oh,
Yeah. All right. So we are basically at the end of class. I'm gonna just I'm just gonna, like, do like 2 3 more minutes on basically something that how does probability help us in our modern world? Basically, it contributes to many factors, but I'd say some main things are like science and medicines. It has helped us understand inheritance patterns in genetics, and how to and drug development. Not those type of drugs. Don't do that, kids. And and it also has helped us make vaccines for COVID-19. It has it has also developed technology and engineering. It, it such algorithms for AI use probability to use probability. We might have a session on AI later, and it also helps us with finance and economics. Basically, with basically it helps us, like, determine the risk of certain events and in stock market analysis. And and I guess another and something it has helped us do. Basically, one of the biggest achievements we have done is space exploration. NASA and other organizations use probability to model and mitigate risks during space missions, which have helped which have helped astronauts and basically have just saved us. Yeah. I did have a slide on this, but since we had 2 minutes, I just wanted to, just get this a little quicker. Well, that is the end of our session. This was kind of a trial session. It didn't go as smoothly as we planned, but yeah, we will have another one coming up.
Let me just finish up really quickly, but thank you everyone for coming to our exploring probability session. So the next time you're listening to a weather forecaster playing a board game with dice, I want you guys to think about where did those numbers come from? Where did those likelihoods come from? And think back to probability and maybe even use that math to make your own decisions. Maybe predict your own weather forecast. Maybe increase your own odds of winning a board game. Right? Probability is everywhere. It's a very important topic in math, and I thank you guys for coming here to learn with us. So before you go, I just want to make sure everyone fills out the feedback form just so that we can always get better with these sessions and we can learn what you guys want us to teach next time. So that's the first thing. Also, the links are in the feedback form, but make sure to subscribe to our newsletter to stay updated for future sessions. So for those ones, I think Rishabh's going to be leading a few more in math or in the future. And we're going to have more on coding and other subjects as well. And then also make sure to join our Discord server. So if you have any questions in general, STEM related, you can ask them there, as well as to see any announcements. That's also in the link to the feedback form. And lastly, I just want to thank Rishabh a lot for this amazing session. So if we could all just thank Rishabh. Thank you.
You guys are free to leave. If you have any questions, please feel free to ask. I do not mind going over. But
Thank
yeah,
you.
if you not if you have no further anything further, we could. Good. Okay, yeah. By the way, this is Vic. By the way, this is Vikram. He's he's a grade below me. Absolutely smart kid. He's smarter than he's smarter than me in math. Honestly, he's super smart. Also, at like a Calc BC level, basically. Yeah, and he's I really excelled in math competitions. Yeah.
Nice. Wait, Vikram, do you want to join as an instructor?
I don't know, sure.
You
All
could,
right.
yeah,
Uh,
we could do a few sections like you could help. Honestly, you'd be really good at it.
Okay.
all right. That sounds great. So just
I'll
message
send them
me
details.
and Rishabh on Discord or something, whatever works, and then I'll get back to you. Actually, there's a Google form you can fill out really quickly.
Oh, yeah, I see it. Okay. Bye.
Sorry, let me get the link really quickly. So that's that. Did you have any questions though?
No, not really.
All right.
Okay,
Yeah,
bye.
you could leave. I'm
All
gonna
right.
talk to this guy in private a little
Bye,
bit. So
Vikram.
that's all right.
All
Okay,
right.
I did so bad, bro.
It wasn't that bad. I think you picked it up. The one biggest feedback I could give is in the beginning, some of like the fundamentals you kind of brushed over and went straight into like problems, which I think
I did skip that favorable out over total. I did skip choosing. Yeah, I did.
but I think
I
in the
was aware.
beginning you want to keep it going at a lower level for much longer. I think you started off good and then like you just had to go into like a lower level for a little longer before you ramp it up. I think everything else was pretty good. Just make sure, I guess, let's try to proof check our slides and Kahoot questions real quick. And
Yeah,
then the Venn diagram part was actually really good. So I'm sorry if I doubted you earlier, but yeah, that one turned out really good.
yeah.
And then did you have an idea for any future sessions?
Not none of this, not this current time, but
So
if
I
I
think
do, I'll get back to you. I would like Vikram to I'd like Vikram to be my assistant instructor, and
uh,
for at least for like maybe 2 sessions, then he can take his own. Yeah,
I think one idea is like, have you done Math Olympiad?
I have.
I mean, one thing we could do is we could just host Math Olympiad sessions, like Math Olympiad or even like AMC 8 or something if you're comfortable with that. But
Yeah.
because I think that's probably in hot demand or whatever.
Shoot, wait, what did I get? I think it was like 2021. I'm not sure.
On AMC 8?
I'm not. Yeah, summer.
That's pretty good. I think I got like a 8 when I took it, but
Nah. Was it in sixth grade?
I think I took it in 8th grade and I got an 11, but we don't have to worry
I
about
mean,
that.
nah, that month I just crammed it in for like 2 months. I did like 5 papers a day.
Oh wow. God damn.
I did not do it was middle school, so everything else was light, so
I
yeah.
think that's one thing if you're good with doing that, because I think you're definitely qualified for it. So if that's something you'd be interested in, we could do that as like the session focus. But
But yeah. But oh that kid's really good. He'll probably get over 20 this one.
okay, then I think yeah,
Yeah.
Vikram matches that pretty well as well.
Yeah, I think now he's in pre-calc. I'm not sure.
All right.
Yeah.
But in general, great job, and just I guess enjoy your break for the rest of it.
Yeah. Oh, and next time I'll do better. I'll come more prepared.
No, it's all right. It's all right. You did great today. All right. See you.
All right. Thank you.